Hi, this is Algebra 1, Module 4, Lesson 9, the arithmetic of matrices. So, still with Elvira and her matrices on figuring out things. Now she's talking about volunteer hours. So, many clubs do not have the funds to pay for parties and events in the cafeteria. Therefore, Elvira lets club members and their parents volunteer for service hours and gives each club credit for the amount of volunteer hours they provide. There are three types of chores the volunteers can do. They can set up tables, mop the floors, wash the dishes. They can volunteer for weekday hours or for weekend hours, which earns more credits. Elvira has recorded volunteer hours for the month of September for the drama club and chess club in the following matrices. So, according to these, the drama club has 12 hours of weekday volunteer, 4 hour of weekend. That's with tables, 8 hours with the floors, 3 on weekends. Dishes on the weekdays is 6, weekends is 3. Chess club, the weekdays, they have 5 hours of table washing. They're setting up tables, 2 hours on the weekends, 3 hours of mopping floors on the weekdays, two on the weekends. Dishes are two on the weekdays and one on the weekends. So write a matrix equation to show how you can combine these two matrices to find a total weekday and weekend volunteer hours for each type of chore. So we are going to do an equation. So now we have to show that we want a total. So if we do a total, that's usually addition, because I want to know how many hours are used washing tables on the weekdays and the weekends. So we're going to add the two together. So let's go ahead and write our matrices. So I'm going to put 12 for I'm going to put this, I'm going to put this matrices and then this matrices, and then we're going to add them together basically. So go back to where I was. There's 12, 4. Next row has 8 and 3. Here, okay. And this one is 6. Just to line them up as best we can. So this is the first matrices. And then the next one I'll put over here. 5, 2, 3, and 2. And then, why I changed color on here. 2 and 1. Okay. I'm going to highlight these and make sure that's all blue and still our 12 font. Okay. Now they're consistent. All right, so I am going to throw in that normally we would have these around our matrices. Can't do that very well with my text box. And it's going to equal a new one. So what I'm going to do to make this new one is I'm going to basically do the 12 plus 5 for my first spot, and then I'm going to do 4 plus 2 for my second. So I'm taking this 12 plus this 5, putting it in my first spot here. This 4 plus this 2, putting in there. So the location of the number is where it's the new location is. So these are all the top left, top left, top left, top right, top right, top right. So let's go back to our text box here, and I'll finish writing the process with this. So middle left would be 8 plus the other middle left, and then it'd be middle right plus the second middle right, and then we'd have bottom left plus bottom left, and then bottom right plus bottom right. So when we go to our final answer, let's just keep everything. Oh, nope, I don't want shapes. Undo. Drawing, wrong button. So now I'm going to simplify this. I should put that first because I don't know how my text box fits. Okay, so 12 plus 5 is 17. The next one is 4 plus 6, 4 plus 2, which is 6. 8 plus 3 is 11. Plus 2 is 5. 6 plus 2 is 8. 3 plus 1 is 4. So my final answer then is this matrices right here. Okay, so the drama club is committed to provide the same number of volunteers hours each month. Let's change our color here. Keep it for all 9 months of the school year. So now we want to show how we want to do 9 months. So this is what, let's see, drama, just drama club. So that's this matrice right here was the drama club, right? Let's just go up and check. Yep, drama was the 12, 4, 8, 3. So the drama club is committed to this. So how I'm going to do this one is I'm going to go ahead and redo its matrice, 12, 4, 8, 3, 6, and 3. But now I want to show that I'm going to times it by 9. So each month for all 9 months is a times 9, right? So I'm going to put the 9 out in front and show it's a multiply. And so what I end up doing is actually distributing this 9 to every spot in the matrix. So my new one then would be 9 times 12 in my upper left, 9 times 4 in the upper right, 8, oh, 9, we'll start with the 9, 9 times 8 in the middle, and then we're going to do 9 times 3, and we do 9 times 6, and 9 times 3 again. So this is kind of the process we're doing. We distributed that 9 to every single one of them, and that's going to equal, let's redraw that in the correct color, equal what those actually equal. So 9 times 12 is 8, times 4 is 6, 9 times 8 is 72, 9 times 3 is 27, 9 times 6 is 54, and 9 times 3 is 27. So this ends up being my final answer then right there. Okay, so now we know how to add two matrices together. We know how to multiply with a matrix. So let's see what our next thing is. Because it's harder to get volunteers for the weekends than the weekdays, Elvira gives more credit for the weekend hours than for the weekday hours. She uses the following matrix to keep track of the dollars per hour earned on weekdays and weekends. So now we want to write a matrix to show how you can combine two matrices to find the total credit earned by the chess club. So now we're looking at the chess club during September for each type of chore. So the chess clubs, I'm going to go ahead and put their matrix here, was 5. I'm looking off the other sheet. I'm going to have to scroll up and down. 3, 2, and then 2 and 1. So if you remember, the left column was, this was weekdays, this was weekends over here. And so now we want to multiply that because we want all of these weekday hours to earn $4. We want all the weekend hours to earn $6. So I would write that as times, and then I'm going to do a 4 and a 6 because this is my new matrix for total earned, right, in each of those. So how that works is I'm going to take each of these rows and multiply it by the column. And then I'm going to take this row and multiply it by the column. And then I'm going to take this row and multiply by the column. So let me go ahead and just back up a tad and show you what I mean by this. So I'm going to come over here and I'm going to take for this top left, for my top left, or I guess it's just the one, right? I should end up with total money. So it'd be 1. I'm going to take 5 times 4 plus 2 times 6. And that makes sense, right? You should get $4 for the 5 hours they did on the weekdays, and they should get $6 for every hour they did on the weekends. And then we want the total, so that's added together. So 5 times 4 plus 2 times 6. That's my first spot. So that's the table setting up, right? Yeah, tables were top. Now let's do the one for what's the total for washing the floors. So that one is going to be 3 times 4, because they get $3 for 3 hours, $4 each, plus 2 times 6. Because those weekends, those hours are going to get those couple extra dollars. Now I've got to do the last row times the column. And so this time I'm doing 2 times 4 plus 1 times 6. So notice in my row, here's my money. My money is times 4. And then my other one, get a different color here. This is this matrix, and the pink is that matrix. So see how they're kind of going across this way times this way times this way, lining them up. So let's do our, oh, no, I need to draw my matrix marks. Okay, now let's put our final answer. So over here, 5 times 4 is 20, plus 2 times 6 is 12. So that's 20 plus 12 is 32. The next one is 12 plus 12, which is 24. And the last one is 8 plus 6, which is 14. So my final answer then, let's move this up just a tad. Oh, nope, that's not what I wanted to do. There. Just tried to move it. All right. So my final matrix is, so they earned $32 for washing tables in a month. They earned 24, or not washing, setting up tables, 24 for washing floors, and 14 for washing dishes. All right. So Elvira's getting good at manipulating matrices, but realizes that sometimes she only needs one element in the sum or product mix. So like, for example, she just needs the cost of buying ingredients at Grandpa's groceries on a specific day. And so she wants to be able to calculate a single result without doing the whole thing. So we had to figure out everything. We did figure out everything. But if she just wanted one, like how much are they earning for um, cleaning the floors instead of all three? So for these below, calculate the missing elements in the sum or product without calculating the rest of the individual elements in the sum or product mix. So basically, can we break it down and only do what we need to do? Well, if we look at this location here, it is the third one in the top row, right? Top row, third column. Well, if I go to the top row, 1, 2, 3, third column, and I'm going to add it with the same position on this matrix, top row, 1, 2, 3, third column, I need to add the 3 and the 5 to get an 8. So that spot should be an 8. Let's look at this bottom one. So this is the second row, second spot. So if I go to the second row, 1, 2 spots, there's a 1. Okay, second row, 1, 2 spots, 1 plus -3 is a -2. Don't think I can write that small, so we'll write them next to it. Okay, so the adding one, pretty straightforward, right? Wherever it is in this spot, I just find that same position in each of these. What about the multiply? So remember we had a column times a row to get each of those positions. So this is the second column, middle position. Well, let me just kind of break this down. So this first row times the first column would get me this first position. If I do the first row times the second column, I will get the second position, first row, second column. So I want to actually take these two times these two to get this spot. So that is just going to do a text box. It's easier to type it up here. So for this one up here, I want -2 times -3. Remember, I'm taking this one. Oh, this one. Can't touch everything if I'm going to. This one times this one plus 3 times 5. So I'm taking the top times. Okay, making sure we're following along here. Plus 3 times 5. And when I do that, I have -6 plus, oh no, not negative, +6 plus 8, right? Oh, 15. Multiply. 15 plus 6. That gets me another text box in here, 21. All right, let's see the next one. Let's use blue for this guy. So this one here is the first row of the second row of the first column. Well, second row and first column. So see how I'm doing row and column to match this up. So I'll do this one down here since we don't have as much space here. All right, so this one I'm going to do 4 times 2 plus -1 times -1. Okay, so 8 plus 1 would be, if I can get that one here, 9. So that one should be a 9. All right, so now let's look at this last one here. This one in purple. All right, so it is the third row, third column. So I need the third row and the third column. That works well that we have one in each of those. And now I'm going to type my process over here. So again, 2 times 4, multiply the first two, and then multiply the second two. 5 times -2. So I have 8 plus -10, which would end me with a -2. So hopefully you see kind of how we did that process of first row, second column, first row, second column, how they work on that one. All right, last couple. 3 times 2 to the -2, 4, -1, 5, -4 times all these. Okay, so this one's a kind of a double whammy here. I'm going to do one step at a time. So think order of operations. We have to multiply before we can subtract. And I'm actually going to make this a plus a -4. So then I remember that it's not just 4 times 2, it's -4 times 2. So let's go ahead and distribute our 3. I'm not going to put every step this time, but I'm going to start by distributing my 3 to all of them in my first matrix, and then I'm going to distribute my -4 to all of them for my second matrix, and then it'll just be a matter of adding the 2 together. So I can change this one to an adding because I've already just took that negative out of there. It's easier to add than to subtract usually. So let's go ahead and type this out. So 3 times 2 is 6. 4 times 3 is 12. -1 times 3 is -3. And 3 times 5 is 15. So that's my first, that's after distributing this 3. So let's go ahead and do the second one. 4 times -4 times 2 is -8. -4 times -3 is a positive 12. -4 times a -5 is a positive 20. And -4 times a Positive 4 is a negative 16. So um, now I've got my two matrices. Let's go ahead and put my brackets on those to be proper on it. And so now I can just add straight across. And I'm actually going to put my answers in this one up here. So, um, so look up here for when I'm putting my answers. So I'm going to do the 6 plus a negative 8 and put that answer up there, which I don't actually need, do I? I only need, because it's telling me, I only need the one that's here. So the second row, second column, or first row, second column, first row, second column, I just need 12 plus first row, second column, 12. So up here, all I really need is to type in 4. And for this bottom one, a different color, bottom one is the second row, first column. Second row, first column is negative 3. Second row, first column is a 20. Negative 3 plus 20 is a 17. Those are really the only two I needed to fill in. Excellent. It's quick. All right. Now this one. Okay. So I'm taking this and I've got to figure out to multiply. So this one's a little trickier in that I have to figure out what I'm multiplying together to get this spot, and this spot, but I'm also missing ones in my original. So let's just kind of break this down and see if we can figure out which one we need to do first. So this one is the first row, second column. So first row, second column, oh look, we've got everything. So that's good. I can go ahead and answer this one, right? Because I've got all my numbers. So 1 times 3 is 3, plus 0 times 2 is 0, plus 0 times 3 is 0. So I have 3, right? Those two equaled 0. So this box should be a 3. Just in case you weren't sure on how I did that, I'm going to go ahead and type over here. I did 1 times 3 plus 0 times 2 plus 0 times 3, right? This is my 1, 0, and 0 from my first column, my first matrix, and then the 3, 2, 3 from my second one. Okay, so I've got that one. Let's see if I can do another one over here. So this one is the second column. Let me go back here. Second row, third column. Second row, third column. Okay, I don't have all that information. I need to have this first one. So top row, third column has to equal 5. Let's pick a different color. So let's see. Let's set this up as an equation. We'll do red since we don't have purple on here. Here we go. Okay, so if I'm taking first row, third column, right? So it's going to be 1 times something. I'm just going to put a question mark in here. Plus 0 times 1 times something, 4, plus 0 times 1 needs to equal 5. Well, if this equals 0 and this equals 0, 1 times what equals 5? Well, 5. 1 times 5. So this must be a 5. Seeing my logic on that one? I get that to fit in there nicely. Okay. So now I have a second row and I have a third column. So I can solve this one now. So let's go ahead and go back to here. We've already done green. Let's do purple. So now I can do second row, third column, and get this one right here. Second row, third column. Let's go ahead and go back and do this one down below here. So I have 0 times 5 plus 1 times 4 plus 0 times 1, right? And those cross out, those cross out. I'm left with 4. So this answer must be 4. All right, we're working our way through them. Okay, so for this last one, I need to have a third row and a third column, which I don't have either for because, or I don't have that third row and I have the third column. Oh, so I can set it up like I did this one right here, right? Because I have everything but one. Oh, no, I'm missing two. I'm missing the third here. So let's see, I need to use something else to figure out that one. So I can use, let's see, third row, second column, right? I've got everything for those. So 3, 2, 3, 3, 2, 3. It looks like the 3 and 2 are going to cancel out because the 3 times 1 is 3. So that means this one must be a 0. Okay, well, if that one's a 0, look at all of our other numbers. 2, 1, 3, 2, 3, 5, 4. What do you think's happening as I'm doing these? Everything's canceling out except the numbers. This is kind of a what do you call like a times one matrix. So if I'm taking this one right here, first, third row, first column, third row, first column, notice my 2 and 1 are going to cancel out with these zeros. So 1 times this has to be a 4 to make it work. Hopefully you're following on this. So 2 times 0 is 0. 0 times 1 is 0. So 1 times something has to equal 4. So that's how I get that one over here, which means if everything over here is the same as everything over here, the only one that's left is a 1. So if I'm taking 0 times 5 plus 0 times 4, those are all 0. 1 times 1 is a 1. So once you kind of see the pattern of that, you're like, oh, now I can kind of see what that is. So that's kind of an identity matrix, because you can multiply anything by it and it gets itself. All right, thank you for joining us today, and we will see you next time.